What we're going to talk about tonight is Windlink. Now, show of hands, how many people have used Windlink before? Neil, I know you have. So about a year and a half ago, it was like just before the pandemic hit, there was a meeting that we had with the West Valley City Club. We actually had it in conjunction with the, I think it was the Salt Lake Crossroads Club. Is that right? Does that sound right? And several members of our club went to that meeting that they put on, and it was like an introduction to Windlink, and they said, bring your computer, bring your stuff, we'll try to get you set up. And they were able to get some of us at least to get accounts created and get on Windlink. And that's as far as it went. We didn't actually do anything with it after that. So, you know, it was, yeah, some people couldn't get it working. And some other people, they didn't bring their equipment, or they didn't have a computer that would work with it. I know I got mine working barely, and then my battery died. So it was, yeah, it was at the library there in South Salt Lake. So I couldn't get on their network and get out either. So we'll talk about why we couldn't do that and some of the things that relate to that as far as how Windlink works. We'll cover that tonight a little bit, but yeah. So I know, Neil, you and I were able to exchange messages back and forth a couple of times. So we proved to each other that we could do it at least. So I think it's cool as a backup. I can stay off the radio, you know, because of traffic and, you know, in an emergency, but you could still get messages through as a text or an email kind of thing. So we're going to talk a little bit about why people want to use Windlink and what some of the advantages and disadvantages are. So just a little background, the Aries group in California, they call themselves the North LA area, or North LAX. They put on a class. It was 4 weeks last month, and they did it on Zoom. It was on Sunday afternoons, and it was really good. I went to all 4 sessions, and I learned a lot about Windlink, a lot more about it than I had known before, and a lot that really turned me on to the whole concept. They talked a lot about the basics of Windlink, how it works, and why people want to use it. And then they got into some depth on some areas as well. We're going to have just kind of a quick overview of Windlink. We're not going to go nearly as deep as they did. They did record all of the classes. They're on a website called Wavetalkers.com. I have a link there on the screen. I will also post a link on the website when we're done. So they are also going to run those classes again starting September 10th. So if anybody wants information on how to get in touch with those guys and sign up for that, I will put that information on the website as well. So I highly recommend them. There were basically 4 main guys who were doing it, and then there was another guy who kind of came in and out, and then they had a 6th guy who is one of the originators of the Iridium network. He came on the last lesson and talked about Windlink over Iridium, and we'll talk about that a little bit too as we go on. So, but it was really good. I highly recommend it. If you can't do it live, if you do it live, it's better because then you can ask questions. And if you can't do it live, watch the recordings because the presentations were really good. So, what is Windlink? Windlink is basically a way to send email via the radio. So one of the goals of Windlink is to provide reliable message passing. Now, when we do an event and we're on the air with our radios, when we did the parade, how many people had trouble hearing what was being said on the radio? It was hard. But a lot of times we were asking for repeats because we couldn't hear, either the band was going by in front of us and you couldn't hear anything but the band, or somebody was, you know, the announcer was talking right when you were trying to listen, or when you were trying to talk, even worse. And so the station you were trying to talk to couldn't hear what you were saying. So a lot of trouble with that. With Windlink, that's not a problem because you're not doing anything with audio. It's all digital.
It's all basically typed messages. It's just like email. And by saying reliable, that means that if you send it, it's going to do everything it can to get it to the designated recipient. And we're going to talk about some of the things that it can do to do that as we move on. Also, Windlink is a global system. It's not limited to your local area. It's not, I mean, you can use it in your local area and you can use it peer-to-peer. We'll talk about some of that as we get into the demo. But yeah, it's a global system. It's not limited. And it operates on the amateur bands. It also operates on some commercial radio services and on the internet. If you've ever heard of a system called SailNet, it's a mechanism for people on sailboats to get in touch via email with their family as they're away, you know, out in the middle of the ocean somewhere. And it utilizes some of the commercial radio systems, but it also uses Windlink to actually run the back end of it. So Windlink integrates with that. Windlink also integrates with the internet email. So from your Windlink station, you can send a message to any email address on the internet and vice versa. Okay, so we'll do some experimentation with that when we get there. The tagline for Windlink, it's Windlink Global Radio Email. That's the registered trademark. It's a network of amateur radio and authorized government licensed stations that provides worldwide radio email using radio pathways where the internet is not present. So, all right. It's built, maintained, and managed by amateur radio operators. So purely on a volunteer basis. It's a nonprofit, right? So it supports email with attachments. It supports position reporting. It supports weather reporting. It supports informational briefings. It's well known for its use in emergency and disaster relief communications. In fact, the hurricane that was hitting earlier this week, Windlink was heavily involved in supporting the emergency services there. The group that builds and maintains it is called the Amateur Radio Safety Foundation, and it is what's the term? Sherwood, a 503c? Is that the correct 501c3? So they are one of those nonprofit organizations. So any donations that you make to them can be tax deductible. So keep that in mind. It can operate entirely without the internet when the net's down. And the website for Windlink is winlink.org. You're welcome to check it out after the presentation. So how does it work? So there's three basic components to Windlink. First, there's a client. And in this example, I use Winlink Express as my example client. And I'm going to show you that in a demo in a little bit here. So don't try to read what's on the screen there because it's way too tiny. The second level or layer is what they call an RMS Gateway. We'll talk more about that in a bit. And then there's also the CMS or central message servers that are out on the internet. And we'll talk a little bit more about that. I've got an architecture diagram here, but these are the three basic components that make Windlink work as a system. So how does it work? You've got your stations that are down here at the bottom. These are your individual users, and they use typically some kind of radio protocol. If they're on HF, they may be using PACTOR, RDOP, several. We'll talk about some of the different ones that are available. On VHF or UHF, you can use Packet. There's also another that we'll talk about in a bit. If you're directly connected to the internet, you can use Telnet directly. So we'll talk about that in a bit too. By radio, you connect to the RMS layer, the remote message servers. And these are systems that people have set up and they run them 24/7 typically. They could be on HF, they could be on VHF, UHF. They can be on more than one at the same time. We'll talk about that a little bit more too. They typically have some kind of connection into the CMS layer, which is out on the internet. And it's actually, most of those are hosted in Amazon Web Services or AWS, if you guys are familiar with that. It's basically a large virtual machine hosting setup that Amazon runs. It's very capable and reliable if your internet is up. So there are several CMS level servers and they all talk to each other. They all share all of the information and synchronize the information between them. So if a message goes into, say, the Southeast USA CMS, it is replicated out to all of the CMS nodes before it's marked as received. So that replication happens automatically at that CMS layer. And that way, no matter where you're at, you can pick it up from that CMS, from any of the CMS nodes. So, all right, talk about the clients. The most popular client for Winlink is Winlink Express. That's the client that typically has all of the features, all the capabilities. It's the one I'm going to demo here. One issue with Winlink Express is it only runs on Windows. Now, it is possible to run it on Linux or on Mac using Wine or using like a virtual machine or something like that. I'm not going to talk about that because that's outside the scope of this briefing. So, but Winlink Express is the most popular client. It's the one that most people use. Then there's also Outpost. There's Airmail. There's a client called PAT, which is fully cross-platform. It's written in the language called Go that was developed by Google. PAT is actually really good. It's very capable. It doesn't support all of the radio mechanisms that Winlink Express does, but it's getting there. Then there's Windlink on Android, or WODE. It's basically an Android client. Android would run on your phone or your tablet or whatever. And there's a system called PAClink that you can run a PAClink gateway, and it will allow you to connect to it with any email client that you might use, whether you use Outlook, Thunderbird, or something like that. You can point them at that, and it looks just like an email server to you, but on the back end, it communicates over Windlink. So pretty cool. All right, so let's talk about some of the communications protocols that we can use. On HF, the typical ones are PACTOR and RDOP, and then there's a new one called VARA HF. We're going to talk about VARA a little bit more in detail later in the presentation, but those are the basic three that you would typically try to use on HF. Now, if you're a HF digital user, you're probably familiar with things like PSK31, what's the other one, RT8 or something like that. Then there's like the old RTTY protocols. These are all similar types of protocols. The idea here is you take the digital data, you convert it into an analog audio signal and send it over the radio. And on the other end, the radio receives it, converts it back into digital form, and then puts it into the software. On VHF and UHF, it supports AX25 packet, which is packet radio. I know Ragnar, you're familiar with packet radio, having used it previously. It also supports a system called VARA FM. Now you notice VARA HF and VARA FM. VARA is the name of the software, and there's an HF version and a version for FM, and there's another version. We'll talk about it more in a minute. So
on HF, how fast is it?
The VARA is the fastest. I don't know the actual bit rates, but VARA, a fully licensed copy of VARA is probably about 4 times faster than RDOP or PACTOR 4. So it's fast. All right, so normally on HF, you're going to be running about 300 baud typically, right? So any additional squeaks you can get out of it by using a better protocol, probably the better off you are. On VHF, you're probably going to be using 1200 baud. On UHF, you can go up, technically you can go up as high as 5600 baud on UHF, but yeah, Ragnar's sitting here shaking his head no. So you pretty much plan on 9600 baud on UHF, and that's probably about where you're going to top out. It also can communicate, like I said, over the network. And by network, I mean your local area network, an Arden network. We'll talk more about that in a bit, and directly on the internet. It uses basically a Telnet protocol. We'll talk a little bit more about that in a minute too. So, when you use it, it feels just like using an email client. Okay, it's super simple. It's like you type in the create a message. you tell it who you want to send it to, you tell it send, and it takes care of it. You can also, like I say here, send and receive from internet email addresses. You can send attachments, so you can send files, images, things like that. You do need to be careful about the size of your attachments, and Windlink will complain at you if you try to attach a file that's too big. It will say, hey, we're sending this at 300 baud over HF. That file is going to take 16 hours to transfer. So something to think about is you want to, if you're sending images, you want to kind of collapse them down to the smallest size you can have them to be able to still get the information across. But if you're in an emergency situation and you need to send, say, the mayor a picture of the creek overflowing its banks, you can take a picture of that, down convert it to a smaller size. You can still see what's happening in the picture and send it via Windlink without having the internet at all. You can also send and receive HTML forms, and we'll talk more about that in a bit too. And they use it heavily in emergency communications environments. So let's talk about a demo. Let's do a demo. All right. I love demos, especially if they work. So let's see. I'm just going to double check that we don't have any chat comments. I don't see any new comments there. Now we have 4 people on. Robert wishes on as well. Okay, so I'm going to start up Windlink. Maybe. Okay, let me put some of this stuff away so it's out of the way. Okay, so this is Winlink Express. All right, everybody see that okay? So this interface, as you can see, it basically looks just like an email client. You have some folders. You can create your own personal folders. You can also set up global folders, and you can maintain a contact list if you want. I have here a list of messages that are in my inbox on this system, and you can see these were from way back in February of 2020 when we went to that other class, and these are actually from Neil. So you can see here, this one says, got your message, and this one says, got it, and there are replies to these sent items. This was my first one. It said, it works, and this is a test message. So you can see how those work. Basically, they're email messages, right? So if I want to send a new message, I go to message, I hit new message, and now here's my message here. So I can say who I want to send it to. Let's say I'm going to send it to Dan, N7XDL. And so you see I put his call sign in there. I'm going to CC it just for fun.
So who always a call sign?
No, it doesn't have to be. It can be an email address or a call sign. So if it's an email address, it'll go over through Windlink and it'll go over the internet to an email address. If it's a call sign, it'll be sent directly to that call sign. Now you can see here, there's a couple of options. I can specify who I'm sending from. So let's say this was a shared system at a EOC or something like that. You could have it configured with multiple users, multiple addresses for the message to come from. And I could, if I was a different operator, I could select a different user to have it come from. I can set how I want to send it as a Windlink message, a radio only message, or a peer-to-peer message. We're going to talk about that in just a second. After I get some lubrication. Okay. So Windlink message is just a standard message that we've been talking about that can go out through the RMS to the CMS and back to another Windlink client somewhere. A radio only message is the same thing, but it will not go over the internet. So it will only go over radio frequency. And then a peer-to-peer message would be, let's say I have my Winlink node set up, and Sherwood, you had one set up. I could send it directly to you without going through an RMS, without going through the CMS, just directly from me to you. That would be a peer-to-peer communication.
And how would? The radio then?
Using the radio, yeah.
Oh, okay.
Or if we were on the same IP network, say we were on an Iridium network together, and I knew his IP address, I could send it that way. So I can request a message receipt. I can change the defaults. So these are just what it's set at right now. If I change this to always do peer-to-peer, I can set that as the default. Notice when I switch to peer-to-peer, that internet address went away. Because if I'm doing peer-to-peer, I can't send it to an internet address. I can only send it to a radio station. Okay. So let's go back to Winlink message. Let me put that back in. All right, I can put in a subject. And then a message body. Okay. Oh, I'm sending this to Dan. He's not here, so I'm going to zoom out a little bit. And then when I'm ready to send it, I'm going to hit post to outbox. Okay. And then what happens is it ends up in this outbox over here. So this is showing that it's ready to send. Okay. But I haven't started up anything that will actually handle sending the message yet. So right now it's sitting on my machine in my outbox waiting to be sent. So there's up here on the top, you can see this open session. And then there's a section here where it says packet Winlink. There's a whole bunch of different methods in here. So we're just going to run through these real quick and talk about them. So there's Telnet Winlink. So this is going to use a Telnet connection, or basically just a regular IP connection, TCP IP connection directly to the CMS, and say it's just going to transfer the text of the message over that connection. If I selected packet Winlink and my computer was connected to a radio, then it would use packet to send it on, say I was on VHF. If I said Pactor Winlink, then it's going to hope that I've got an HF radio and some kind of Pactor modem set up on my machine so that it can send it that way. RDOP is here. There's Vhf, FM, and then there's Iridium Go. I don't know if you guys are familiar with the Iridium network, but the Iridium satellites were put up a little while back. It's basically a satellite phone system. And it also includes a data capability, right? So what it is expecting here is that I've got an Iridium phone attached to my computer, and it will use that to send the message via the Iridium network. Mm-hmm.
It looks like a GPS. Well, it is going through, but we're using those to send messages.
You can send bidirectional messages, right? Yeah, it's a similar type of thing, right?
I use it because I don't have phone service when we go out and do our camping.
Right. So those are options I can use. I can also say send it packet peer-to-peer, Pactor peer-to-peer, robust packet peer-to-peer, RDOP peer-to-peer, Vhf peer-to-peer, FM peer-to-peer, Telnet peer-to-peer. That's what, remember I said if we were on the same IP network, I could send it directly to them that way. And then down here, I could say Pactor radio only, Vhf or FM radio only, or Telnet radio only. And there's also Telnet post office. I have no idea what that one is. We never talked about that in the class, so I haven't even looked that up yet. I'm going to pick Telnet Windlink because I don't have a radio hooked up to this thing right now, but I am on the internet. So I'm going to pick packet or Telnet Windlink. I'm going to hit open session, and you'll see here, this little window pops up, and it says it will automatically connect in just under 16 minutes. Well, I don't want to wait that long, so I'm going to go ahead and hit start. And you'll see that it says connecting to a CMS, connected to CMS at this timestamp. And then there's some communication protocol here where it says, hey, here I am. I've got a message to send. It's going from KD7 ZWV. And then it sends the message. And then it says completed send of message. And then it tells me I sent one message, 277 bytes. It took 0 minutes and 0 seconds and sent 72,837 bytes per minute. And then end of session. And then my session messages say messages sent 1, total bytes sent, blah, 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 messages received, total bytes received, etc. And then it says disconnecting, disconnected. And then it drops back to now it wants to reconnect in about 8 minutes. So if I just leave this running, in about 8 minutes, it's going to try again. It'll connect up to the CMS and see if there are any messages for me. So in an RF environment, what would typically happen is I would send it via a RMS gateway. So remember we talked about that middle layer. There's that middle layer of RMS gateways. So I would send it probably using packet on my VHF radio to an RMS gateway. And that RMS gateway is either going to have a Telnet connection into the CMS, or it might have an HF connection into some other RMS gateway that can reach the CMS, or it might have some kind of VHF connection to some other radio or some other mechanism to get to some other RMS that gets it to the CMS. If it can't reach the CMS, it will tell me that when I try to send it. It'll say, hey, I don't have connectivity, so don't send through me unless you really have to. And then I can pick a different one. I'll show you that in a second.
Okay. Like with packet, you make a connection to another station, and it's an open connection.
Right.
This
is the same type of thing, right? It's going to do that same thing. So I'll show you. Let me start it up. I'm going to go ahead and open a packet Windlink. I'll open the session, and you see here it says connection type direct KF7 GNV10. That's the RMS gateway that it thinks I want to send it to. So it's going to try to make a packet connection to that node on packet radio, right? How does it know that? There's this button right here, this channel selection button. Let me pop that up. And what it does is it actually maintains a list based on where it knows I'm at. I've told it what my grid square is. Based on where I'm at, it says, hey, these are some VHF and UHF stations that are nearby you. Okay. So if I see that I want to send it to this guy, for example, right? West Valley City nodes, right? Exactly. So it tells me he's about 13 kilometers away from here, pretty much due west. And I can do it on 1200 baud on 145.05 or 9600 baud on 421.500, right? I can pick any of these guys. These are basically all of the RMS gateways that are within 300 kilometers of me. Now, I might have a hard time reaching this guy that's 290 kilometers away, but if I've got a Yagi antenna pointed at him and he's got one pointed in my direction, we might be able to do it. Now, one of the things that the guys in LA did in one of their exercises, they do an exercise periodically. In their exercise, they actually were able to hit via VHF from North LA, a node in Tijuana. It's about 145 miles or so, with a direct link. Again, that was with a Yagi antenna and knowing, that it was, they wanted to do this, and the guy in Mexico had an antenna pointed back at them. So they knew what they were doing. But if you're in an emergency type of situation and you're sitting there in LA and you can't get to the internet because the internet's down, but the guy in Mexico can, you can reach it out to him and get to him that way. So I can pick one of these guys on here. And if I do that, now it wants to send it direct via K2 WBC10, right? I can also digipeat. So if I can't reach K2WVC10 directly, but I can reach it via another node, I can put up to 2 more nodes in here, and it will digipede out to get to that node that has the RMS gateway on it. So
you're basically doing something like APRS.
I'm doing similar to that, where I'm taking advantage of the infrastructure, the packet radio infrastructure that is existing, and being able to take advantage of that. So one of the things that they showed us in the presentations of last month was one of the guys is like up in this canyon, and he can't reach the RMS directly from where he's at, but he can reach another guy's station here. And from that station, he could digipede down into the RMS. So that's his mechanism, is to always do that when he's on VHF. So those are some of the options that you have available. They've actually well architected the system, so you can do this pretty cool. I can also change to script, which allows me to actually tell it, go to this node, then do this, then do that. And there's like a whole language that you can use to program that up. I haven't looked into that at all. I haven't needed to, obviously. So I'm going to go ahead and exit this one.
So if you do reliable path,
you could use it. Yep, you could specify it and know that it's going to work. And so that's something that why you want to have exercises periodically and do this periodically, to prove to yourself, yes, I know how I can get there in an emergency, because I know how I can get there anyway, right? So I have a reliable mechanism to do that. All right, so let's talk about what should we talk about next here? What else did I want to demo? I'm going to go back to Packet Winlink, and actually first I'm going to go into my email and show you that I received this message. Remember, I CC'd my own email address on here, and this is what the message looks like in my real email client, right? So it's from kd7zwv@winlink.org. Anybody with an email address can send an email to kd7zwv@winlink.org, and I'll get it via Windlink. Okay, so if I want to do like a reply on this, all right. So I sent that, and of course it went to both my Windlink address and Dan's Windlink address. So next time he gets on Windlink, he's going to get some serious hate mail. So, all right. Assuming he ever gets on, right? So, all right, let's put that back away. So we go back to Packet Winlink. I'm going to open that session again, and go ahead and do, no, I didn't want Packet. I wanted Telnet Winlink. Open session.
Now, if you had a radio hooked up to your.
I could do the packet, right? I wanted to do that, but I couldn't find my cable. And I was afraid that being in here, I might not be able to reach the West Valley City node. So I can do it from my house with an antenna outside. I can't do it from inside the house with my handheld. So all right, I'm going to go ahead and start this again, and you'll see that it connects out there, and it says, hey, look, here's a message. I'm going to go ahead and download it. And then it shows here in the summary, messages sent 0, messages received 2. And so I'm going to go ahead and exit this. Normally I would leave that open, but I'm not going to do that right now. And then I can go to my inbox, and I can see I got a message from Vern. Did anyone order pizza? Thanks, Vern. Vern is on Zoom with us tonight. He's still in quarantine waiting for his surgery. So that's why he hasn't been joining us. But he sent me a demo message. So that's cool. Thanks, Vern. And then here's the message that I replied to from my email address. And you can see it's from my email address here. And there's my reply. So isn't that pretty slick? That's pretty darn slick. I think this is an amazing tool when you start getting into it and start seeing what you can actually do with it. Okay, what's that? Harriman, I think, or I'm not sure where he's at. Vern, where are you at? Go ahead and type it in the chat so we can see it. Or don't. Yeah, like, oh, he is in Sandy. Okay, cool. So he was able to send that from his computer using Windlink. And you notice he sent it from his call sign to my call sign. So I picked it up via Telnet to the CMS. I don't know if he used radio to get it there or if he used Telnet. It doesn't tell me that. I don't need to know that. I don't really care. All I know is I got the message. And if I wanted to reply to him, I could very easily shoot a reply to him just like I could any email message, right? All right, so let's go back to the presentation. If I can find, all right. All right. Okay. So, whoops, what did we do there? We're on demo time, current slide. Okay. All right, so recommended configurations. So what do I need to make this work, right? Obviously, I need a computer of some kind. And there are Android versions. So remember I showed you in that list of clients, there's that Android version. I don't know of any iOS versions, unfortunately. So Apple phone and iPad users, I don't have a solution for you. But ideally, you want to have a Windows computer. So let's see, we got a message. He's in the basement and used Telnet. Okay, cool. Thanks, Vern. All right, so recommended configurations for VHF and UHF. If you're going to use packet radio, you want to either have a TNC and a radio, or a radio with a TNC built into it. We'll talk a little bit more about that in a minute. Or you could have a software TNC like UZ7HO, some kind of audio interface and a radio. If you want to use VARA FM, and we'll talk more about VARA a little bit later in the program here. If you want to use VARA FM, you need some kind of an audio interface because VARA FM acts like a software TNC. And then you need a radio attached to that. On HF, if you're using PACTOR, RDOP, or VARA HF, you need some kind of audio interface and an HF radio. And then I have other here. We kind of glossed over using Iridium. That's the other that I'm talking about, right? So we'll talk about that more in a minute. But, let's see. So first, let's talk about what's a TNC. So I said you need a TNC if you're doing packet. A TNC is a terminal node controller. It's typically a little hardware box that has a connection that goes to your radio and some kind of audio input and output from your computer. So, or some kind of, not audio, a serial input and output from your computer. So you would typically plug this into your computer on a serial port or USB or something like that. And then you would hook the other side of it to your radio. And what it does is it's basically a modem, okay? So if you guys remember way back in the dark ages when we used to use dial-up modems, this is basically the same kind of thing. It's gonna take your digital information, convert it into audio tones, and send it out over an audio connection. Your radio is going to take that in on its microphone port and send it out over the air. Anything that the radio receives, it's going to send out through its speaker port. The TNC is going to receive that, demodulate it back into a digital signal, and send it onto your computer. So I put up some examples here, the Contronics KPC3, MFJ has one, the MFJ 1270X, which is based on the TNCX. There's also the Mobile Link D, they have TNC3.
Excuse me, how much do they cost?
I have no idea. I know the Mobile Link D TNC3 is about 120 bucks. The TNC2 that I have is was about 70 bucks when I bought it. So the difference is the TNC3 will work with iOS devices. Doesn't help you for Windlink, but if you're doing APRS or something like that, then you can use APRS clients on your.
The West Valley one, if I remember.
Which one is it?
One that West Valley.
Oh, yeah. So we'll talk about that in a sec. I think it's about 60 to 70 bucks for the Pi Hat. So you can also have a radio that has a built-in TNC. I know Ragnar, you've got a THD7 and you've got a 710, 700. So the mobile rig is the 700. I've got a D72. Neil's got a D74. I know somebody in the club has a 710. I'm not sure who, but those radios have a TNC built in. Kenwood has been very good about exposing the TNC interface on their APRS capable radios because they say, hey, I've got this TNC in here, you might as well have at it. Yaesu has a bunch of radios that have a TNC in them, but you can't get at it. There's no way to get at it from a computer side. Yeah, you can use it for APRS inside the radio, but you can't access it as a TNC. So that's a bummer, but that's a design decision that they made. I don't know of any other radio manufacturers that are selling radios that have those built in. I do know that the D72 has been discontinued, the D7 has been discontinued, the D74 has been discontinued, the 700 has been discontinued, and the 710 will be discontinued in, I think they said March. So if you want one, you should get it. These radios cost anywhere from $400 to $800, but you know, if you want that kind of thing, that's something to think about. There's also a gadget called a Pi TNC hat. So if you've ever used a Raspberry Pi computer, a Raspberry Pi is a single board computer. It's about this big. It has a row of what they call GPIO ports on it that can be addressed from inside the computer. And a hat is a little board that sits on top of that and gets its power from the Raspberry Pi and interfaces to the Raspberry Pi through this interface. And what this one does is it basically acts like a sound card and TNC all rolled into one little tiny board. They're made by Matt, I can't remember his call sign, in West Valley. He sells them on Etsy, of all places, but they're about 60 to 70 bucks assembled, and if you can also buy them as a kit, I think. So, but keep in mind, on the Raspberry Pi, you're not going to be running Windows, so you're not going to be running Winlink Express. You can run PAT. I know people have been using the PAT client on it, and it works well. So that's something to think about. Let's see. So audio interface. So I talked about how you could have a TNC or you could have an audio interface that connects the computer to the radio. And most of the guys in LA are using these gadgets called a signal link. These cost about 140 bucks. They're not cheap. They're not crazy expensive, but they're not cheap. Basically, I have one on my computer. Hold it here so you can see it on the camera. This is the signal link. There's a RJ45 on the back, and you have a little cable that goes from there to the radio, and they sell a dozen different kinds of cables with different connectors on the other end to connect into whatever kind of radio you might have. And then on the front, well, it also has a USB port. It connects into your computer via USB, and it looks like a sound card to your computer. So when you set it up on your computer, it says, oh, look, there's a sound card. And you tell the Windlink software to use that sound card, and it'll go through your signal link. It has some adjustment dials on the front, so you can change like the gain or sensitivity of this microphone and the speaker that are essentially in the sound card that's inside here. You can also set the delay, which it looks like a Vox device, a voice operated transmitter. So it will key the PTT on your radio through this cable, but to the software on the computer side, it makes it look like a Vox operated device. So the software isn't trying to send a keying signal to the radio. It's depending on the signal link to do that. And this delay lets you set how long it holds that connection open and how early it closes it, opens and closes it before it sends the actual signal through. One of the things is, since it has a standard RJ45 on here and a bunch of different cables, there's a lot of things you need to know about your particular radio and what the pinouts are on your radio. And I actually have this open. I'm gonna pass this around, so don't get grubby fingers poking at it, but hold it from the end here. But it's got this little socket here, and it comes with a set of jumper wires that you can use to tell the signal link what connections coming in from the radio do what thing. So if you look on there, it's got some labels: PTT, mic, and speaker, and then some ground connections. So depending on what your radio wants, you set the appropriate wires inside here, and then when you plug your radio cable in, everything magically works. So pretty cool little gadget. I'll hold that in front of the camera so people can see that. And then I will pass it around. Put it by the edge of the card. We'll buy this. Probably stay away from the panel. But you just hold it.
You can pass it. I've seen it. You got one? No. I did have one.
It's a pretty simple little gadget, pretty well made, works really well. One of the cool things about it is it actually isolates the computer from the radio side. So there's a couple of little packages on there that are, I think it's actually using, I don't know if it's using opto isolators or if it's using transformer isolators, but there's no physical wired connection that touches both the radio and the computer side. So even if your computer is generating some kind of background hum from the AC circuit or whatever, it's not going to get on the radio. So
Yeah, I noticed that on the 1270, a lot of interference from each other. So I love that machine. I think I talked somebody into taking it.
okay, so another option, if you don't want to buy the signal link, you can build your own. There are a couple of other things out there. I did some poking around. I didn't find any anymore. I had one from, I can't even remember the name of the company now, but I never was able to get it to actually work correctly. So I don't have a problem buying the appropriate hardware if that's what it takes to make things work. But if you're interested, you can build your own. There's some circuit diagrams and some information on these links that I have on the page here. And again, I will put all of these links on the website as well. So, but basically what this does is connects your computer to your radio. Also, if you're doing HF, you need some kind of control cable that goes from the computer to the radio so that the computer can tell the radio what frequency and what band to select. Okay, so most HF radios have one of these, what they call a cat port on it. Not all of them do, but most of them do. Some of the newer HF radios have a sound card built in, and they have a USB port on the back. You can plug it directly into your computer. You don't need any of this stuff. It just plugs directly into your computer. But if you got a little bit older radio, if it has a cat port, that's what you want. Then the software can actually set the frequency for you based on the station that you're trying to connect to. I didn't show you in the application. I've got another demo coming up, and I'll take a minute to show you then. But just like you can download that information for nearby VHF stations, you can download information about HF stations as well. So it'll include things like what frequency they're on and what band and all that kind of information. So, okay. So the VHF UHF side does not support automatic radio control. So you have to set your radio to the appropriate frequency for the station that you're trying to connect. The way that they need to be, you don't have to muck with them anymore. So unless you want to switch to a different radio. They also do sell a little pin package that plugs into that socket for certain radios, that so you don't have to figure out where the wires go and plug them in. It's all built into a little package. You just drop it right into that socket and you're good to go. So all right, so let's see, where are we at here? Okay, so other, let's go back to what we were talking about. Remember, we had HF, VHF, UHF, and other. Well, other would be the internet protocol. So Windlink uses that Telnet protocol, works anywhere that you have internet access. You can also run it over an Iridium network. And we did a presentation on Iridium a while ago. If you poke through the website, you'll see the recording of that somewhere. I can't even remember how long ago it was. It's been a while. Iridium is basically a IP network running on commercial Wi-Fi gear, but on ham frequencies. So what it allows you to do is have an IP network, like a Wi-Fi type network, that runs on ham frequencies that you can use for ham radio stuff, right? And you can run the Telnet protocols over that network as well, just as over the internet. So if you've got an RMS gateway out there on your Iridium network, then you can connect to that and use that directly. One reason why you would want to do that is it is fast and it doesn't say anything to you about large sized attachments because, hey, it doesn't care. It's, 2.4 gigahertz or 5 gigahertz. It's, you can run 100 meg per second over something like that easily. So that's a good reason for us to look at setting up an Iridium network here in Murray for emergency services. That's outside the scope of this meeting. We'll talk about that another time, but yeah, that's something that I think we should definitely look at doing. All right, so let's talk about some more advanced stuff. RMS Gateway. So remember I talked about how we have this tiered structure where we've got the clients, we've got the CMS at the top, we've got the clients at the bottom. In the middle is this RMS Gateway. So what this is basically just some software that people run on a computer that's attached to one or more radios and typically attached to the internet somehow. So it can run multiple protocols at the same time. So you can have what they call a hybrid gateway. Could be listening on VHF, UHF, HF, Iridium, and an IP network connection. So it is very happy to be able to accept connections on all of those and move the information up to the CMS. One thing about the RMS is, let's say your RMS can't reach the CMS. I mentioned that when you connect to it, it can tell you, hey, I can't reach the CMS, so I can't push your message all the way up. You could actually say, I don't care about that, just hold on to it. And then another station, the station that you're trying to send to, if he connects to the same RMS, he can pull the message down directly from the RMS without having to hit the CMS. So in a situation where the internet is down, if you're using it locally and you've got a local RMS set up, it doesn't matter if the internet is down. If you're doing all of your information traffic passing locally, you can still do that without the internet. Okay, so we also talked a little bit about digifeeding already. We kind of went through that a little bit based on Ragnar's prompting. So you can route messages via digifeeding. If I have another node that can reach the RMS and I can't, I can send it to him and he'll automatically send it up, right? Attachments, I said images and files. There's another thing we'll talk about in a second, form. Okay, so Windlink supports sending forms over this connection mechanism. And I blocked out some more demo time here. So let me drop out of here and put this down. We'll go back to our Winlink client. And before I do that, I want to do this real quick and show you. If I said, let's say I said Pactor Winlink, right? And I open that session, it wants me to set up my TNC, which I obviously don't have here, but I could set whichever kind of TNC I have. If I had this attached like to a serial port, obviously I don't have any of this set up. I'm gonna go ahead and close that for now.
West Valley groups on there.
I don't know, let's find out. So if I go to channel selection, and I'm gonna do update via internet. You see there's update via internet. There's also update via radio. So if I don't have a connection to the internet on my machine, I can still update from any other RMS that has this information. I can get the information from them rather than having to get my computer in connection with the internet. Okay, so let's see, K7DAV is available 24 hours a day. He's 37 kilometers from me. It estimates a reliability of 99%. So, and he's due north of me apparently. I don't see West Valley City on here. I think I would have seen it. It's sorted by distance, and the only things that are within 100 kilometers are K7DAV. It also shows here what modes he supports. Pactor 1, 2, 3 on this frequency. So he's got his radio set up, and it's actually scanning between these different frequencies. So his RMS gateway that he's got running there will change his radio to this frequency and it'll listen for a bit. And then it'll change it to this frequency and it'll listen for a bit. And then it'll change it to this frequency and it'll listen. And then it'll change it to this frequency and it'll listen. And then it goes back to the top again. So it's watching all four of these frequencies. And if it hears me trying to connect on HF, it'll stop and handle my connection and take my data. This does not use a TNC. This would use something like a signal link. It would use some kind of an audio interface from the computer to the radio, and then it would use the Pactor software on the PC side. Okay, so this is Pactor that's out there listening. Let's see. We can also try RDOP. And then this would be the RDOP setup. Again, I'm going to cancel this because I don't have an actual RDOP node set up. Whoop. And it said, hey, fool, you can't do that. So we won't do that. Anyway, so that's basically it. You can do the same kind of thing that you did with the VHF. You can get a list of who's out there and pick the one that you want to reach out to. Most people on HF use what they call an NVIS antenna for this. So it's designed to reach out a short distance. So it's not like a long distance. You can do a long distance connection. And if you looked at that, let's go back into that real quick. It was showing me, I can open that up again. Channel selection. So it was showing me stations that are thousands of kilometers away from me, right? So obviously it thinks none of those are good. Go back up to the top of the list. So it thinks that this guy that's 37 kilometers away would be good. If my beam is set to go straight out and bounce off the ionosphere some 1,000 miles away, I'm probably not going to reach this guy. So most people are using what they call an NVIS antenna setup, like an inverted V or something like that, which wants to go basically almost straight up, bounce off the ionosphere and come straight back down again to hit something within 100 miles or so of you, right? So you can, like if I'm in a situation where everybody around me can't reach the internet because the internet's down, I can pick somebody who's like 1,000 kilometers away and try to do a connection to him, just like I would do a normal HF connection, right? A normal HF contact. I'm obviously at the mercy of the ionospheric gods where that comes in, but yeah, so
Yeah, like on HF, it's very difficult sometimes to get anyone close.
it can be very difficult to get somebody close, right? Because of the way the propagation works. And, you know, again, sometimes you might hit them via backscatter. You might, you know, there's lots of different things that happen in HF, and that's why you want to experiment with it and find out what works for you at various times of the day. Something that works for you at noon might not work for you at 10 p.m., right? Or vice versa. So, you know, you want to experiment with that. You want to play around with it and get a feel for what's actually working for you so that you can take advantage of that. All right, so we're going to talk about the forms. So let's see if I do new message, right? I can do a new message and I can select a template. And I have this list here. This is the template manager list. There are standard templates. And I'm going to go in here to, let's see, general forms. And here's a Windlink check-in form. And if I click on that, what it's going to do is bring up a browser window with this HTML form in it. Okay. And I can click and add the time and date. I can say that this is an exercise. I can say I'm doing this on VHF or not applicable. I'm doing it on Telnet. I'm sending it to that WVC, what was it? A7 WVC? A7 WVC. Let's see, my call sign, KD7ZWB, and any others who are here, who the sender is. So I could list multiple call signs here. I can say I'm in Murray, Utah. If I had a GPS connected to my computer, it would automatically populate the GPS coordinates here. I don't, so it won't do that, but I do have that. It does have that capability. So if I've attached a GPS receiver to my computer, then the computer will know where I'm at and it can plug it into this form directly. And then I can say any comments that I want to say here. So as they say in the notes here, on batteries, need relief in 6 hours, situation report, operator names, special notes for the next shift, mode being used, or whatever, right? So then I can hit submit, and it says click OK. And what it does is it'll go back to Windlink and it'll compose the message. And it'll say, hey, this is a form message. So it's attaching this XML file that contains this information. And it puts in just the data from the form, not the entire text of the form. So that form could be 100K or something like that. I don't want to send 100K every time I fill out the stupid form. I only need to put in the data that's part of the form. So it'll put that in and it'll encode it in here. And then if I hit send on this or post to outbox, I'm not going to go ahead and do that right now because
I noticed whenever I do it, it brings up, you know, brings the page on the default browser. Is that the information going from, is it off Windlink or is it off?
it's off of the local machine. So it's got copies of all these forms. And when you first start up Windlink, if you haven't run it in a while, and you first start up Windlink, one of the first things it does is says, hey, I'm going to go out and grab the latest forms, and I'm going to check and see if there's a newer version of Windlink. And if there is, you probably want to install it. Now, unfortunately, what typically happens, at least what happened with me, when I fired it up on this machine, which I hadn't run it on in a year, the first thing it did was it said, oh, look, there's a new version of Windlink. You better install it now. So I said, okay, install it. And then it finished installing and it said, oh, look, there's a new version of Windlink. You better install it now. So I installed that. And then it said, oh, look, there's a new version of Windlink. You need to install it now. So I installed that, 4 of them. There were 4 updates, and each one had asked me each time to install. So that's something that I wish they would fix, where it would just say, oh, the latest version is here. here you go, right? But I don't know if there may be some migrations that happen to the internal data and stuff like that, how it's stored on the machine. They may not want to maintain that outside of a particular release for multiple back releases. I don't know. They probably have a reason for doing it that way. But if I had written the update code, I would have done it a little differently, but that's just me. Anyway, so as you can see, it puts this information together in this form, and it sets it up so that if I send this, just the data that's part of the form will go to the recipient. And when he goes to look at it, it'll actually pop up his browser window with his copy of the form and populate it with my data. So he can see it just as though it were a handwritten form or hand-typed form that I handed to him physically. So that's pretty cool. There's a ton of different forms out there. We can go look at, you know, there's FEMA forms, there's general medical, like a hospital bed report, how many beds are in use at your hospital. There's the IARU form, ICS forms, all of the ICS forms for the standard, what is it, RACES that uses those?
RACES, I think a lot of there's RACES uses those. I think some other groups use those as well, say, okay, this is what we've done.
There's USGS forms here. There's weather. So if you're doing like, what's the weather watch thing, storm watchers? There's a form you can fill out right here that we put in all the information, shoot it right off. They get it, they can decode it, do whatever they need to do with it. You don't have to mess around with anything. To you, it looks like you're filling out a form. When they receive it, it looks like you filled out a form. You've got a form sitting in front of you. This is the killer feature of Windlink, if you ask me. This capability right here. Plus, you can have your own forms, or your organization can have their own forms as well. So it's very easy to produce these forms. It's basically an HTML file with a little bit of CSS attached to it and maybe some JavaScript. Not complicated if you're a competent web developer. So if you have, your organization has a particular form they want to use, relatively easy to take that and convert it into a Windlink compatible form. So there's also a bunch of forms online that are not in this list that are available that you can download and install on your machine if you want to use those forms. So seriously, this is the killer feature right here. This is the feature that makes using Windlink the preferred tool for this emergency communication. So anyway, like I said, I'm not going to send that. I'm going to close it. I'm going to discard that and go back to presentation. Okay, so let's talk a little bit about VARA. I've mentioned VARA a couple of times. I mentioned VARA HF. I mentioned VARA FM. There's also another one called VARA SAT. VARA SAT is for satellite use. It's specifically for the QO100 satellite, which we can't see because it's in geosynchronous orbit. So it's always over the same part of the Earth, and it's basically over Africa. So if you're in Africa, Europe, some of East Asia, most of East Asia, probably you can see it. Can't see it from the Americas. So we don't need to talk about VARA SAT at all after that. So we'll talk a little bit about VARA HF, VARA FM. So VARA was developed by this operator who observed that some of the protocols that we were using for our modulation and demodulation of digital data are not necessarily the best protocols. So he developed this protocol which uses kind of a spread spectrum technology. And it actually, on a good, clear connection, it can get really fast transfer of data over a regular, 25 kilohertz wide FM frequency. And it can do really good on HF as well. But he only opens it up for lower speeds unless you pay a license fee. And also the DigiPeak capability of Vara is not opened up unless you pay a license fee. It's about $75 for the license. He will accept a group buy where if you're buying 50 licenses or more, we'll drop the price to $50 each. So
How long is that license good?
it's perpetual. And the same license is good for both Vhf and FM. So if you buy it once, it's good for you forever, right? The issues that people have with it are the protocol is not well published. It's not something that you could easily reverse engineer. And because of the way our regulations are in the US, technically you're not supposed to use any kind of encoding where the encoding mechanism is not published, right? So people are still using it because it's super effective, but you need to be aware that some people don't like that and will yell at you for using it because they don't think you should. One of the cool things about it is on a packet station, for example, you can run like on your RMS gateway that's on a particular frequency, you can run both the VARA listener and your packet listener, and it will happily receive whichever one happens to be transmitted and respond appropriately. So you can run them at the same time on the same frequency on the same radio without having to dedicate one radio to just VARA and one to packet, for example. So that's kind of cool. I have mixed feelings about it. I think the whole I mean, I don't have a problem with him wanting to make a little money, but again, we're not supposed to make money on ham radio, right? So technically he's not making money on ham radio. He's leveraging some software that he wrote to make money, and it happens to use ham radio, you know. So he's making money, but yeah, I mean, it's a gray area. He's not from the US, so our rules don't apply to him. So, you know, it's one of those things, right? So if you want to check it out, you can download it, you can play around with it. The LA guys rave about it. They use it all the time. It does give you a lot better connectivity. It's a lot more robust in its signal handling. It's more likely to get a signal through, even if it has to go through at a slower rate, because it has this kind of spread spectrum type technology behind it. So I don't know all the details about the implementation, obviously, but they say it's really good, and they like it and they use it. I'm probably going to buy it just because probably ought to have it. Better to have it and not need it than need it and not have it, right? So anyway, take it with whatever level of salt that you want, whether it's a grain or a mountain of salt. That's up to you. So that's all I've got. Questions, comments, things of that sort.